This is a source of sound. It is moving with a velocity, say v1. Here person moving with a velocity v2, and there is a truck. Okay, this is a source. It's a siren, you can put it. Now let this move with a velocity for you. Okay, siren is mounted on the car. Okay, it will siren. So actual frequency of the siren is F. Then there's a truck is moving. So there's a rear end of the truck. It's a good reflector. So here the person is between the siren and the truck, that one. But all three are moving here now. Let V be the speed of the sound. Let me put all this one. Let V be the speed of sound. Let F be the actual frequency of sound emitted by siren mounted on the car. Okay, and the car is moving with a velocity v1. So now what will happen? This will put siren, ambulance, whatever be that one. So it is going to generate a sound, so sound waves of frequency f. The person is going to hear one direct wave. The other wave, what will happen? Will go get reflected by the rear end of the truck and will be heard by the person. So now find the, what you have to calculate is find the apparent frequency of direct incident wave and reflected waves, and the reflected waves that are reflected by rear end of truck. Same, the wall is moving is what I'm bringing it. Huh? Okay, how you manage here? What is u? Let it be in terms of u. U will bring it. U V F, that one. Okay, the truck, no, that every truck's the rear end, what pen will be like a moving wall. That's what I just picked up. Work out now. Use the same Doppler effect formula. I think just it's only practice now what we did earlier, the wall at rest. Now here the wall is also in motion. Now we'll get into first between the car and this one. So let me use the same again, we'll get confused. Only between these two, we'll take this one first, the direct wave. Just you have to understand the method, no? I think it's not something very big. Huh? It's a very easy. First a direct wave. Let me call this is F1. This is a direct wave, no? What is the apparent frequency? F1 is equal to, and V minus V2. V2 is what you know. Next step, I'll substitute here. And this will be V minus V1. What is V2? V2 is U. F by, this will be V minus 4U. So this is the frequency of direct wave. Next again, frequency of wavelength of direct wave. What is V relative? Anybody? Can you say what is V relative? Speed of the waves with respect to observers. So the waves, what happen, will be moving with the speed V. They will come and strike from behind. No, what is the relative motion? So the wave is moving towards side. Person is moving towards side. What is the relative motion? V minus U. I think this you are quite very familiar now. Huh? This is wavelength of direct wave. So this is about the that. Okay, let's talk about the now indirect waves or the reflected wave. First, what will happen? The waves emitted will reach the rear end of truck. So the rear end of truck will be like a secondary observer, will receive the waves, will be reflected back. So how the rear end of truck will behave like a secondary observer with respect to source and will behave like a secondary source with respect to the person. Because how the person will receive, first the waves will be received by the rear end of truck, will be reflected. The reflected waves, what happen, will be incident on the person. So first I should discuss the Doppler effect between the siren and the truck, between the car and the truck. Next, Doppler effect between the truck and the person. Getting the methodology. Let's take the diagrams. It will be easy for you to follow. This person will remove it because this person is not needed. No. Okay, this I think you are quite comfortable like this. The one diagram I'm trying to explain clearly. So this is F, call F dash. No problem, that is. Okay, now write the F dash. What is F dash? F dash and not F1, F dash it is. Frequency of the waves received by the rear end of the truck. So they should be equal to, the truck will behave like in a secondary observer. So what you should write? Behaves as a because it receives waves, no? So what is this F dash? F dash should be equal to V3, or so V minus V3 by F by V minus V1. This should be equal to V minus V3 is 3U by V minus 4U. Okay, no, this truck with respect to observer, how do it will behave? That we'll see. Luckily, I'm able to have a diagram. At least you'll understand this very clearly now. Huh? Clone. BOS has a secondary source, so it will generate waves now. This is what F dash, and this is what F2. This is what reflected wave. Got the idea? This is, so shall we go for F2 now? Relative motion between them, Doppler effect between them. These terms are very important. I just made things very clear. Just make observation. So what is F2? I should write F2 should be equal to, who is observer now? Is observer. Huh? Not truck is not a truck will be like a secondary source. Secondary source it is. So F2 is equal to it should be like a V minus V2 F dash by V minus V3, which is equal to U by V minus 3U. What is F dash? V minus 3U F by V minus 4U. Wait. Source moving away, no? Should be positive. Huh? Just check. Let me check the calculation all. This is source, no? Source moving away should be positive. So therefore this will be positive. Yeah. Okay, it should be like this, yeah. Check once calculation, positive, negative signs. V plus V2, ma. Yeah. V plus V2. Oh, yeah. Here also one. Yeah. V plus V2. So V2 is you know. Just verify once. So what is this? There's a frequency of reflected wave. Got the idea? This one? Okay, now wavelength I want wavelength. In what action the person is moving towards right? In what action the waves are the reflected wave is moving towards left, no? So therefore that V relative by F2. What is that V relative? Speed of the wave V minus of, or say like a V2 minus of minus V. V2 is what? U plus V. What is F2? I need some space. So the wavelength, what happened? Better let's calculate in every case so that it will become easy for you. If you look at the books, no, they have just shown like a 1 or 2 cases. The students will find very difficult. So from the beginning, I started. From the beginning, what happened? I just made you to think on the wavelength. So you'll be on little bit better position. V relative will be V plus V2, I'll write it. And we know F2. F2 is V plus U. V plus V2 is what? V2 is you know. So these two will get cancelled out. So we'll end up with Now, where is the person? Person is in this way here. Is moving in between the car and the car and the truck. Moving wall means similar to like the rear end of the truck, because it'll be usually, I think now if you when you move on highways now, you can see these conditions like this. The rear end of the truck will act like a reflecting wall. And now you have plenty of questions. What are plenty of questions? Like if you check it now, the person, so many cases will come into picture. The person what when will be moving towards left, the truck car will siren will move towards left, the truck will be moving towards left. I think some other easily other 8 cases will come. We have discussed one of the case. So you take one more thing and try to work out. It'll be easier for you. I just shown one of the cases. The truck will be moving towards left also. No, it can be. The person will be moving towards left also. Anything can happen. In all the cases, work out the both wavelength as well as frequency. Don't wavelength, make a practice of getting the wavelength. See, once you know apparent frequency, you can get wavelength very easily. Then just make a practice of getting the wavelength. So you just try to assume like different. So if it's moving towards left, here on in this problem, if the person moves towards left, some changes will come. Again, the same Doppler effect formula. Next, if we have a situation where